Hi everyone, today we're going to be looking at the Freight Carrier Weighing and Distribution, EasyPLC. Now the Freight Carrier Weighing and Distribution will demonstrate sequencing and shift registers on the EasyPLC machine simulator. Product comes in two different ways and must be organized, weighed, and then delivered on the correct output ramp. This will be based on the weight of the product. The EasyPLC simulator Freight Carrier will show you how you can control this process through a programmable logic controller. Learning PLC programming can sometimes be challenging, but EasyPLC allows you to practice and learn your ladder logic skills on the controller of your choice. It is the best method of learning industrial control PLC programming. Now, using the 5 steps for PLC programming development, we will discuss and show you how to program this Freight Carrier Weighing and Distribution simulator. An Automation Direct Click PLC will be used for this application, but the general methods can be used for just about any PLC on the market. This PLC simulator will show you sequencing and shift register programming. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. The first step of PLC program development is to determine what must be done. The EasyPLC software suite contains this Freight Carrier example in the machine simulator. Start the EasyPLC machine simulator, or MS. Select the Start button on the main page or select Machines from the main menu on the top of the machine simulator window. All of the available machines will now be displayed. Click on the 09 Freight Carrier Weighing and Distribution. This is the example that we will be programming. To the left of the screen, information will be displayed on how the freight carrier needs to function. It basically says distribute the goods along the conveyor line, managing the tables to give priority to each of the entry lines. The goods have to be weighed in the balance system. The boxes must be sent to the exit ramps according to the following criteria. Ramp 1, boxes of 20 kg weight. Ramp 2, boxes of 15 kg weight. Ramp 3, boxes of 10 kg weight. Ramp 4, boxes of 5 kg weight or less. The machine simulator has a demo mode for the built-in machines. This will allow you to watch the operation of the freight carrier. Select the demo mode. The freight carrier demo mode on the machine simulator will operate, showing you the basics of operation. Move around the 3D environment. There are 3 icons on the top window that will allow you to move around this 3D environment. The first icon is the default selection. This will allow you to move around without bumping into components. The first person mode will mimic a person in your 3D learning world. And the last icon will automatically show you around this 3D virtual environment. Once we have a good understanding of what must be done, we can now move on to the next step in our PLC program development. The second step of our PLC program development is to define the inputs and outputs. The View I/O at the bottom of the machine simulator window will display the inputs and outputs required for the freight carrier example. While still in demo mode, you can see the operation of the inputs and outputs. The EasyPLC Freight Carrier example will require 24 digital outputs and 22 digital inputs. It will also require an analog input for the weighing system. The PLC Start mode will allow you to manually control the freight carrier simulator. This is ideal if you are unsure as to what an output or input is doing. Select the View I/O at the bottom middle of the machine simulator window. You can now manually run the robotic cell without any control or PLC connected. You can now use Select and start the freight carrier digital outputs on the left side of the screen by clicking on them with the mouse. The right side will show you the corresponding digital input. The Restart button on the bottom of the machine simulator window will reset the scene back to the start. Selecting the analog input on the right-hand side will display the weigh system analog input. Step 3 of PLC program development involves developing a logical sequence of operation. Now, a PLC programmer must know everything about the sequence and operation of the machine before programming. The freight carrier is an excellent way to learn programming. A flowchart or sequence table is used to understand the process that needs to be controlled, and it must answer questions like the following. What happens when electrical power or pneumatic air is lost? What happens when input and output devices fail? Do we need redundancy? This step is where you'll spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting the PLC logic. Knowing all these answers of how the system is to react is vital in the development of the PLC program. Our freight carrier machine is split up into 4 different sections. We will walk through the logical sequence of operation. Splitting the requirements up into smaller sections will allow you to concentrate on the task and not get distracted by other parts of the program that are unrelated. A startup timer of 5 seconds will be used when the machine starts so that all boxes that are on the conveyors will be moved to the end of the conveyor lines. This will be common to all of the different sections. The first section will deal with conveyors 1, 2, and table 1. It will also create a part on conveyor 1 if nothing is detected at the end of the conveyor. If a box is on the end of conveyor 1 and no box is detected on the table, then the box is moved to the table. When the box is on the table and nothing is on the end of the conveyor 2, then the box will move to the end of conveyor 2. When this section is running in full, a box will be at the end of the conveyors and on the table. Section 2 will be similar control to Section 1. This will control conveyors 3, 4, and Table 2. Table 2 will alternate getting the box from conveyor 2 and then conveyor 3. Section 3 will control Table 3 and conveyor 5. If the box is present on conveyor 4 and no box is on Table 3, it will be moved onto the table. If a box is on the table and not at the end of conveyor 5, the box will be moved to the end of conveyor 5. Now Section 4 will control the weigh stations and exit ramps. When no box is detected on the weigh station, the box at the end of conveyor 5 will be moved onto the station. When a box is detected at the station, a timer is used for 2 seconds to allow the weight to be read. Depending on the weight read, a shift register is enabled for the exit ramp. Our example will have 3 shift registers to track the first 3 exit ramps. The last ramp will be the smallest weight and will reject everything that is detected in front of it. Normally a shift register will track parts by a mechanical gear on the conveyor belt, but in our case we'll be using a pulse time bit of 500 milliseconds. The sensor beside each of the reject cylinders will ensure that our timing for the reject is accurate. Now, a PLC programmer must know everything about the sequence and operation of the machine before programming. Writing out what is supposed to happen will help you clarify what is required in the PLC program. This is just another method like flowcharts and sequence tables, so ask questions or view existing documentation to ensure that you know the logical steps of the machine operation. Step 4 of our PLC program development is developing the Click PLC program. Using the information from the previous steps, we can now program our Click PLC ladder logic. We are using the Click PLC programming software. This fully functional free programming software will allow you to program ladder logic into Click PLC. The Click PLC series will take you through installing the program, communicating to the controller, instructions and addressing of the controller. A link has been put in the description below. So the first thing we will do is ensure that we can communicate to our EasyPLC simulator, and we'll look at the communication port. So we'll go to Setup and then to Communication Port, and we will select port number 1, which is the Ethernet port that we have here. And you can see here that we have set a static IP address of 192.168.1.230. So that is important to know exactly what that port is before we start programming. So we'll just hit OK for that. And then we'll hit cancel. The other thing we can do is take a look at our Modbus TCP setup, and that's the way which we're going to communicate to the controller itself. And right now the Modbus TCP will act as a server. So that means that it will just sit there and wait for instructions from the simulator to get the inputs and outputs updated. So we're going to ensure that it's enabled for our Modbus TCP server, and the default port is 502, and we have 3 concurrent sessions, and we have a 60-second timeout. So these are all the defaults that actually will be on a click. Just hit OK. So that is our setup of our controller. Next what we'll do is take a look at the actual program itself, and you can see here that we're going to have that initialized timer. So we have a hardwired start and stop push button, and we started internal bit here, C1, and you see it self-latching. So this is our start stop circuit, and then we have a timer that does our initial timer for 5 seconds because it's in milliseconds here. Next we'll take a look at section 1. So in section 1, what we do is we advance this roller when we have our start initialized time and not finished yet, and it will keep that conveyor roller 1 advancing. It will reset upon the photo 1 cell. And then we have our table sorter. So again, during initialization, we turn on the table 1, and when it's not there, or when it's out, then as soon as we have signal number 3, then we know that we have a box on that unit itself. Next we have our table sorter 1 move, and these are the conditions here now that we have our sort table moving and the reset. And finally we have our work part creator. And the work part creator, what it will do is when we don't have a box there, we will actually start and turn it on, and that's will create a box on conveyor number 1 for us. Section number 2 is similar to number 3, except we have also introduced a flip-flop circuit. And the flip-flop circuit, what it will do is alternate between loading table number 2 with a box from conveyor number 2 or number 3. So it alternates so that it equalizes the distribution of those boxes. Then we have conveyor 4 movement. And then we finally have our work creator. This is creating a box on conveyor number 3. And you'll see all these sections are documented so that you can go back and review and exactly see how that logic is actually being applied. So section number 3 controls conveyor 5 and roller table 3, and this moves the box to the actual weigh system and the exit ramps. So again, very similar logic to move that in there. Then finally we have section number 4, which contains our weigh system. And we have our belt, which is weigh system 55 reverse. This sets the belt on and stops the belt. So when we don't have a signal and when we do have a signal. So once we have the box coming into that weigh system, we look for that signal on photo cell number 9. When we do, we actually turn on our weigh system here, and we also start a timer. And when we have also our initial bit, we also do conveyor belt number 2. So we have, after the time expires, we have a box moving onto with the conveyor belt number 2 and also the weigh scale belt. And what we do is then we control our ramp number 1. And ramp number 1 actually looks for 20 kgs. So what we do is we look at our weigh scale here, and when our time system is finished, then what we do is we start loading the shift register for data. And our clock bit is 500 milliseconds. So this is what keeps the counting going, or the sequencing of our bits going through our unit. And then when we have our stop, this is what resets it. Our initialization sets our shift register, so it zeroes it out. Then what we do is we pick up one of these bits here in our shift register that lines up with where physically it is on our conveyor belt in order to do the pneumatic pusher. So basically, as soon as it pushes it and we see photo cell number 10 on the leading edge, then what we do is we send it out and we push that box onto the exit ramp. That's provided it has the reading scale of the 20 kgs that we're looking for. And ramp number 2, we do the same thing, except for now we're looking at 15 kgs. So it's very important that you'll see that this tracking of this bit through the shift register. Then we have ramp number 3, again 10 kgs, same type of logic that we are using. And finally ramp number 4, what we do is we ensure that if it's 5 kgs or less, so in other words, anything that comes past that is going to be less than that because it hasn't rejected from the previous 3 ramps. So we just look up the photoelectric signal, number 13, and when we see that, we actually apply the pusher and push that box onto the exit ramp. And that is the end of our program. So that is our entire program that we have. So what we want to do is we want to then connect to the actual PLC itself. And we hit the connect, you'll see that we have a couple different methods. This is the one that we set for our static IP address. And that's the one we'll hit, click on it and hit connect. And when we do, we're going to not read from it. And so now we are communicating to our actually PLC. And if we actually look at the hardware, you'll see that I have my Click CPU right here. And we have our 2 inputs for our start and our stop for our program. And we are communicating through our Ethernet port. And that's located right here. So what we want to do is we'll just write this program down to the controller. And we'll say OK. And we'll proceed with a runtime edit. And now we're writing that into the controller. Okay, so now we're all set for the next step, which is the testing of our PLC program and our monitoring. So you can see right here we have our status lights, so we're actually monitoring what's actually happening. And we'll wait till we can get connected, then we can start this program. Step 5 of our PLC program development is to test the program. We will be using Modbus TCP on our Click PLC to communicate to the EasyPLC machine simulator. We will call up our freight carrier in start mode. And you will see that we do not have currently our PLC connected here. So we will go to IO drivers. And it defaults to the EasyPLC driver. We will change that to Modbus. And we'll hit the configure. And based on our inputs and outputs that we are using on the Click PLC, there's 25 inputs and outputs, and we're using the one output here for our weight. So we'll just hit OK. And there is our 230. That is our IP address that we set previously for our static. We'll hit OK. And then it brings back the outputs, or the PLC inputs, and the driver inputs, which is the PLC outputs here. And what we will do is we can move this over to the inputs and these ones to the outputs, or we can get driver and automatic assignment, and it will automatically assign them for us, which is an easier way to do this. Then we can exit and then start driver and exit. Now we have our driver connected to our PLC. So once we have the driver connected to the PLC, we've already determined that we have our program downloaded to our controller. So now we can just hit the start button. And then what we do is you can see that we have our start initialized. And once it's finished, it then starts after the 5 seconds, we start moving our boxes along our conveyor. We can set the view IO, and we can actually view that IO. So running this, you'll see that we can load up all the boxes, and then we can look at our weigh scale, and we can actually move around this environment in order to see exactly what is happening. We'll go over here, and we can back up, and we can see that our weigh scale is measuring, and we are placing those boxes where they're supposed to be based on the weight of the box itself. So our shift register and our IO bits are actually operating. If I look at the actual PLC program, we can see that all of our bits are operating accordingly, and we can monitor those at the same time as our simulator is operating. So this is where we're going to troubleshoot and look at our PLC, and you can see how it's ejecting the boxes to the appropriate ramp. And this is all done with our shift register, and we can take a quick example or look at our actual data view. And in data view, you can see that here's my example for the bits going to the last register. So as you can see, our values, and you can see the actual box itself turning those bits on and then going down. And then finally, when it sees that light for that final eject or reject station, it'll actually fire that box onto the exit ramp. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.